The first question regards the P66 Chic protein, which negatively affects glucose metabolism, modulates oxidative stress, and plays a major role in inducing cell apoptosis and aging. Metabolic dysfunction associated steatotic liver disease, MASL, formerly known as non-alcoholic fatty liver disease, NAFL, is also associated with diabetes, oxidative stress, and hepatocyte senescence. Of concern, type 2 diabetes is also a risk factor for fibrotic progression of muscle. Therefore, it could be reasonable to speculate on the potential role of P66 Chic protein in the fibrotic outcomes in MAST. Conflicting with this prediction, however, P66 Chic deletion or deficiency protects from obesity, but not metabolic dysfunction in mice and humans. Please comment on these seemingly conflicting data in view of a possible research agenda in this field.
Thank you very much for this question, and also let me also take this opportunity to thank you for accepting me as part of the editorial board of the journal. I'm very pleased and honored to be part of this distinguished group of researchers. Regarding, again, the question about the role of P66 Chic in metabolic dysfunction and specifically in the liver, I think we have some data. We still lack some other data, but it is clear that this protein is very important in mediating oxidative stress. So this is a very broad process of cellular and tissue damage that occurs in multiple cell types, multiple tissues, and also it does occur in the liver. We actually published almost 10 years ago a paper in which we looked at the effects of P66 Chic in HepG2 cells. Of course, we're talking about an hepatoma cell line, but we were able in this cellular context, in this cell type, to show that overexpression of P66 Chic can promote generation of reactive oxygen species. So it does promote oxidative stress. And also, importantly, it does promote oxidation-dependent DNA damage. And this is also an important component of the alterations that occur in hepatocytes in the context of metabolic dysfunction. In that study, we also analyzed the signaling pathways by which P66 Chic promotes these negative effects, and we identified different intracellular kinases that are activated by overexpression of P66 Chic, for example, MAP kinase, AKT. There was also an involvement of FOXO3A, which is an important factor in shifting between the nucleus and the cytosol that is associated with cellular oxidative stress. And so we concluded that P66 Chic is important as a mediator of hepatocyte damage. At the same time, by looking at some biopsies from individuals, from human subjects with alcoholic steatohepatitis, so I understand we're not talking about muscle, but we're talking about alcoholic steatohepatitis, we found that in these specimens, in these tissues, there is an increased hepatocyte expression of P66 Chic. And so we have at least some evidence in humans that there's a modulation of the levels of this protein that correlate with conditions of liver damage. Now, you were asking also about possible research agenda and how to sort out potential conflicting results. There was, in fact, another paper in which, as you mentioned, the deletion of P66 Chic was not able to protect from metabolic dysfunction in mice. Well, that's something that can happen if you, first of all, you look at data from rodents and from mice as compared to humans. But I also would like to state that this is only one component that regulates the redox balance in cells. There are also other components. So it is possible that by inhibiting P66, you may not be able to switch down to inhibit, to counteract all of the mechanisms that promote oxidative stress in hepatocytes. And it is also possible that there are additional pathophysiological processes other than oxidative stress that can, of course, favor metabolic dysfunction of the liver. Of course, inflammation is another very important aspect. So I think this is an important player, but probably not the only player.
Myokine irisin exerts a protective effect on beta cell function. Additionally, it also exerts an anti-steatotic effect in high-fat diet-fed mice and in HG cells exposed to palmitic acid. Do you believe that irisin could be a novel therapeutic target for the management of metabolic disorders and muscle?
Yes, I do believe so, because irisin is really a very potent molecule. It was, as we know, first discovered as a myokine, so a protein released by skeletal muscle in response to exercise, favoring the white to brown adipose tissue conversion, so favoring the browning process and the thermogenesis. So this was the initial discovery of irisin many years ago by the group of Bruce Spiegelman. Since then, many other properties have been found to be elicited by this myokine. For example, we discovered some years ago that irisin is not only released by skeletal muscle in response to exercise, but also in response to excess fatty acids. So if you expose an animal to a high-fat diet, there is an increased release of irisin from the skeletal muscle. And at the same time, irisin is able to protect islets in the pancreas and specifically beta cells from fatty acid-induced apoptosis and fatty acid-induced cellular dysfunction. So there is ample evidence that there is an interplay between excess fat and irisin. It looks like irisin sort of is activated when there is an excess fat, especially saturated fats, and it does protect many organs from lipotoxicity. So I'm not surprised to see here that in high-fat diet mice and also in HepG2 cells exposed to palmitate, irisin did prevent the negative effects and the cellular damage occurring in response to these metabolic stressors. It is very much coherent with what we know from other cell types, specifically the beta cells, but also what happens in other tissues. Irisin is a potent anti-lipotoxic factor. So whether this could be a potential new therapeutic target or agent in the management of muscle, I think this is something that deserves other studies. First of all, there is no study at the moment that shows that you can administer irisin to humans. Actually, we have a patent. Our group has obtained several patents around the concept that irisin can be protective for beta cells, but we need to exploit this discovery further to characterize irisin as a potential drug in humans with the proper toxicology studies, and then start with some additional investigations as phase 1, phase 2 trials, which is not something we can do tomorrow, but it takes time, and hopefully it will be done in the next years.
Based on your long-lasting experience in endocrinological research, would you like to comment on the role of sex hormones on the development of diabetes and target organ damage, notably including muscle?
Yes, I think it's a very interesting and timely, discussion. We have to consider more and more the impact of sex hormones and, in general, of gender on disease, and specifically in diabetes or metabolic liver disease. Certainly, as I said, is a very intriguing and timely topic to be addressed. In general, I don't think there is much of an evidence that gender and sex hormones affect the development of type 2 diabetes. So if we consider the prevalence of type 2 diabetes in men and in women, it is not very different. There could be some differences in the time to development of type 2 diabetes. For example, how long it takes for men and women to transition from normal glycemia to glucose intolerance to type 2 diabetes. But we are talking about not major differences there. Whereas in terms of muscle, so metabolic disease-associated steatotic liver disease, there is some interesting new data showing that estrogen generally offer protection against the development of muscle, whereas androgens like testosterone may favor the development of muscle. So that's something that has been known for some time. And a recent study also showed that if you look at these process of development of muscle in female and in male mice, you can see that exposure to excess fat is something that is handled differently in the different gender mice. So female mice tend to store lipids mainly in subcutaneous and visceral adipose tissue depots, whereas male mice tend to increase the ectopic deposition or accumulation of fat in the liver. So this is coherent and consistent with the concept that androgens may be important for shifting the accumulation of lipids in the liver rather than in the subcutaneous fat, for example. And also the pattern of estrogen receptor subtypes is slightly different according to gender. So there is, I think, interesting preliminary data that suggests that one can potentially look at the development of muscle as a gender-related kind of disease and possibly recognize the estrogens as a beneficial, of course, component in this process.
Expanding on the previous question, number 3, do you feel that gender-affirming therapies in transgender individuals could be a useful model to explore this topic? Or do you feel that utilization of supraphysiological hormonal doses may hinder our understanding of physiological association?
But this is a difficult question to answer, first of all, because we don't have much data. There is very few data around the investigation of metabolic disease in transgender individuals. And also we have to recognize that we are here looking at different situations. So trans feminine people or trans male people, they may behave differently, of course, and it's not easy to look at this data in the context of what happens physiologically, as you already mentioned. We have one study showing that, for example, if you look at the development of type 2 diabetes, this seems to be like 30-40% more frequent in trans feminine individuals. So people that are male to female, and of course are treated with hormones, with estrogens, and maintain the phenotype as compared to the cisgender female control group. So this is a little bit against the possibility that taking estrogens may be protective for the development of metabolic disease. But of course, we have to consider that we are treating with estrogens people that have a male condition as a genetic background. So I think it also tells us that it may not be easy to make easy comparisons between transgender individuals and what happens in these people as compared to what we want to know about males and females. So I think we need more data, but my perception is that we are talking about different situations and different biological conditions.
Tirzepatide is effective in the reduction of fasting glucose and body weight among subjects with type 2 diabetes. Do you believe that this drug has a profile of sufficient safety also among individuals with metabolic dysfunction associated with steatohepatitis and advanced muscle fibrosis?
Well, this is a very interesting topic, and of course, we are already, fortunately, seeing data that are consistent with the positive role of tirzepatide in metabolic disease of the liver. First of all, I would like to recall that tirzepatide is a dual GLP-1 GIP agonist that has been developed for the treatment of type 2 diabetes and for the treatment of obesity. It does promote a very extensive weight loss, and because of this, certainly there could be beneficial effects in the context of muscle or MASH. At the same time, there could be some direct effects of the drug on the liver, even though we know that the reduction of hepatic fat is very much related to the weight loss that these individuals experience when they are treated with tirzepatide. So there was already a study, which is the SURPASS-3 sub-study on liver fat that was published a few years ago. SURPASS-3 is a study in which I was also involved, which compared tirzepatide with basal insulin in people with type 2 diabetes inadequately controlled with oral agents. The study showed that tirzepatide is superior to basal insulin. In that study, the insulin used was degludec to reduce HbA1c from baseline, and also was superior, obviously, in promoting a major weight loss, whereas insulin did cause an increase in weight, in body weight. So there was a sub-study I was mentioning of SURPASS-3, which focused on what happened in the people with type 2 diabetes in terms of the hepatic fat content. It was really striking to see that tirzepatide caused a major reduction in hepatic fat over a year period. This did not occur to the same level with insulin therapy. So this was the first evidence that you can have favorable effects of tirzepatide in the context of MASLD, I would say, so steatotic liver disease. Then, however, there was a specific study, which is a study in a phase 2. It was a phase 2 trial, the Synergy NASH study, which evaluated tirzepatide in people with biopsy-confirmed MASH. They also had moderate to severe fibrosis, so F2 to F3. And the study showed that there was over a 52-week period, so over a year of treatment with the 3 doses of tirzepatide, 5 milligrams, 10 milligrams, or 15 milligrams once weekly. There was, in many patients, a very nice effect in terms of resolving MASH without worsening the fibrosis, and also improving the stage of fibrosis without worsening MASH, so the steatohepatitis associated with metabolic dysfunction. So the data are pretty clear and definitely support the development of additional phase 3 trials, which I understand are underway, in which we will probably have additional evidence of the efficacy of tirzepatide in the context of MASH. And so possibly we will have a special specific indication of using this drug as a therapeutic option for people with MASH.
Now I am going to change completely my topic of discussion, and I will ask you, as a leader in your field, you are certainly exposed to innumerable requests to act as a reviewer for many submitted manuscripts. The editorial activity is presently experiencing a dramatic shortage of qualified reviewers. What is your opinion about whether and how reviewers should be incentivized?
Well, this is a critical question and obviously refers to a situation that is also evolving over time. So in the past, we never considered that we needed to find some incentives in order to have reviewers on a given manuscript to be evaluated. Was felt many years ago there was like a honor, to be invited to review a paper, especially if the paper was submitted to a prestigious journal. And we know that this reviewer activity was and still is considered to some extent in terms of evaluating the CV of a scientist and potentially also considering the promotion to a higher level role in the academia. Nevertheless, this is the past or something that still occurs to a limited extent. Here we have, I think, less emphasis on this activity in terms of academic evaluation. There is at the same time a wealth of journals. There are too many journals, and some of them I'm not even sure if it is right that they exist, but they are still there. So we have so many requests to review papers. And of course, each one of us has difficulty in complying with all these multiple requests. So one possibility would be obviously to recognize payment, for a honorary for this activity. And this was also discussed in a prestigious journal, in The Lancet, in an editorial in which it was proposed, or was at least discussed, that one could think of compensating the reviewers for their work, because of course it is work, it is time consuming, it is energy consuming in terms of course, intellectual energy, and it is precious. It does provide value to the journal. So why not thinking of a monetary incentive compensation for the time and expertise that is provided for the review process? I am not against this. At the same time, I don't think this is the only way to favor high quality reviews of the papers. You can think that unless this payment, this amount of money that is given to compensate the reviewer is substantial, this is something that could make younger and potentially less experienced reviewers review a paper as compared to more experienced and also higher quality scientists do this, because they may probably not be that much interested in a compensation. So I don't think it does necessarily solve the problem. At the same time, I think it is important to consider that if we want professional service, we need to consider that this is not always and forever to be conceived as something that needs to be done for free. So it does have a value, and there's a need to at least understand how this value of the reviewer process, of the reviewing process, should be sort of considered and weighed. So I don't have the solution here. I think we also should consider to have maybe not too many journals requesting so many reviews from scientists. We have to also consider that some of the journals do not necessarily, consider these reviews to the same extent. And so I think this is also important. So the time that is provided to review a manuscript should be also valued not only in terms of its potential economical or financial amount, but it should be valued for its intellectual contribution and should be always considered at the highest level possible.